System initialized.
Greetings everyone and greetings Sir Jamus. We are the Group 4. Welcome to our Midterm Laboratory Quiz 2 presentation. I am Radyn Ryu Maloles and today we are tasked to do the Disaster Response Command Ops. So this is a Java-based system specifically designed to manage and streamline relief distribution during emergency operations. Before we dive into the technical details and architectures, I would like to introduce the development team behind this system. I am joined today by my teammates, Cassandra Nicole Sante, Silan, and April Joy Franco. To give you a high-level overview of our system, the Disaster Response Command Ops is an object-oriented programming application that its primary purpose is to coordinate relief operations as efficiently as possible when the disaster strikes. So the complete system is built upon 9 Java classes and validated through 12 rigorous test cases. We have organized the system's architecture into 4 core modules. First is the people module, which manages our personnel, such as responders and coordinators, using role-specific data. Second is the communities, which represents the affected zones and track vital metrics like populations, risk levels, and dynamic urgency. Third is the logistics, which handles supply items that are grouped into functional batches with calculated values, weights, and priorities. Finally, the missions module serve as the central development hub containing our responders affected communities and supply batches into unified rescue operations. Moving on to the structural design, we have heavily utilized object-oriented program principles, specifically inheritance, to keep our codes organized and reusable. At the foundation of our personal data is based on the person class, which hold generic attributes like name and sex. Branching off from these, both responder and coordinators inherit from the person class. So our responder includes specialized um, operational fields like ID, assigned zone, rating, total missions, and efficiency. So a coordinator focuses on the management with an IT zone and rating, and the operating independently of the personal hierarchy. We also have the community class, which monitors locations, populations, risk level, and urgency index. Lastly is the supply item class, which manages our logistic data, detailing item IDs, categories, base values, weight, and priority levels. To give you an complete pictures of our file structure, here are the 9 specific Java classes that make up the entire application. As mentioned, the person acts as the base class for fundamental human attributes. The responder and coordinator extend this base class to act as our field agents and zone managers. Respectively, the community represent the physical zones affected by the disasters, while the supply item defines the individual types of relief goods available. For the inventory management, we use a batch item as a wrapper to link an item with its required quantity, which is then grouped into the larger supply batch. So the mission class ties everything together as the core operational component. And finally, the main serves as our driver program containing all the executable test cases. So let's take a closer look at our personal management implementation. Our base person class encapsulates the basic attributes of a string name and string sex, complete with the standard getter and setter methods to access and modify this data safely. So the responder class extends this base class and introduce critical field data including an integer ID as an assigned zone string and a trackable performance matrix like the rating, missions, and average efficiency. Importantly, it includes then an update performance method to dynamically adjust a responder statistics based on their field success. So similarly, the coordinator class also extends persons that is tailored for the regional oversight. So it contains an ID, an assigned zone, and a performance rating along with the necessary getter methods to retrieve this management data. So for the furthermore explanation of the codes, So please welcome Christian Silan to explain. Thank you.
Dangal greetings everyone, I'm Christian Garcilan and for today's video, I'm going to explain the main.java of our program. So first, let's start with this block of code. So this block of code is So this block of code perform the initial setup initiating a community object named zone A with a defined population that reads parameter alongside responder object name 1 with a specific rating location. So it's then utilize formatted printed statement to output structured data log. So confirming that both target community and assigned personnel have been successfully registered within the system. So next block of code, log. So next block of code is this code block initialize an individual supply item. So object for food and water, defining their specific identification codes, market values and weights for or before aggregating them into a single supply batch container. So it's conclude the generating of a formatted log and confirm the successful compilation of these resources, ensuring all logistical data is properly tracked for the upcoming mission. So our next block of code, this means this code segment initialize a mission object with unique identifier, distance the difficulty factor, and formally links the previously created community, supply batch, and responder to that mission. So once these association are set, the system prints deployment summary for verify all mission parameters personnel have been correctly assigned for execution. So let's proceed to the next block of code. Uh, this block of code means this code triggers analytical function of a mission object calculate both financial requirements and project success rate. So based on currently assigned resources and environmental factors, this is by executing a compute mission cost and compute mission efficiency. So the system generates a data-driven forecast that allows operators to review the estimated budget and mission effectiveness for final execution. So let's proceed to the next block of code. So this block of code simulates the reception of a real-time intelligence, manually updating the community's urgency index. These two critical value of 11. So the following these updates, the system triggers the compute priority score. Okay, it's compute the priority score function and recalculate the mission and the threat level. So resulting in significantly higher priority status that reflects the increased severity of the situation. So let's proceed to the next block of code. So this code means that uh, updates the responder official record by passing the mission efficiency and success result into the update performance method. So then prints the updated metric showing the new average efficiency and performance rating to provide a data-driven evaluation of the responder field work. So the next block of code, it means this code demonstrate mid-operation logistic adjustment by adding the medicine item to the existing supply batch, which increase both total value weight of the payload. So it then triggers the recalculation of a mission cost, ensuring the financial budget accurately reflects the new added resources before final deployment. So this or next block of code, it means the system ability to scale operation by initiating second responder object named Pedro. So with his own unique ID and performance rating, by calling it assign responder. So they call the method assign responder. The mission now manage multiple personnel, which is confirmed by a console output signaling that backup has been officially deployed to the field. So next is the display summary. So this first block of code, this means um, generate the visual header and the primary data section of the after action mission report using structure box drawing characters. So to have some UI design. So it dynamically populate the report by fetching mission critical data such as the mission ID, target community, and priority score while utilizing a for loop to iterate through list every responder currently assigned to the operation along with their individual performance. So next block of code, this code means that create structure selection within the mission report dedicates to delivered cargo, clearly listing every resource sent to the field for employs a for loop to iterate through the supply batch dynamically printing each item category, quantity, monetary value, and weight to provide transparent audit of the logistical payload. So next block of code is the final block, which is conclude the reporting sequence by printing the final mission cost and final efficiency rating within the some UI, the stylized border. Um, this it's significant the end of the program execution by displaying the system shutdown message. So indicating that all computation, data updates, and reporting tasks for the midterm or for their system have been completed. So this is to provide some user interface on our program. So that's our main Java program. Let's proceed to the um, to my part on our presentation. Greetings. So again, I'm Christian Silan, and in this video, I'm going to explain some part of our presentation that connected to our program. So first, let's start with the core computation on slide number 7. So compute mission cost. So this function calculates the total financial requirements of our mission by summing the base value of all items and adding transport fee based on the total weight. So the final cost is the scaled to specific multiplier. So and we have a dist mult and if uh, NV mult. So this which account for travel distance and the environment difficulty of the operation. So next is we have the compute mission efficiency. So the module or this evaluate the success of the mission by analyzing the ratio of the supplies delivered to the population size and comparing the actual execution time against the expected time frame. So these factors are multiplied the responders and average performance rating and scaled by 100 to produce a final efficiency percent or final efficiency percentage. So next, we have the TC4 work example. So in this box, provide a step-by-step. So next, we have a TC4 work example. This box provides a step-by-step application of the cost formula using a specific scenario where 800 units of items and 35 kilogram of weights result in transport cost of 175. So by applying 1.5 times multipliers for both distance and environment, it demonstrates how the final mission cost of 2,193.75 is mathematically derived. So the next is our update performance or the TC8. So this function manage long-term data tracking by updating responders cumulative scores and mission count every time task is completed. So it calculates the new average, so average efficiency. So it uses success rating and determine the final rating, which serve as a definitive measure of a responder's reliability over time. So let's proceed to the next slide. So on the next slide, we have a test case, TC1 to TC12. So let's have some short explanation of each TC. So the first is the entity int. This case initialized the system by creating the primary actors, specifically establishing Zone A as a target community and one as a assigned responder. So next is the TC2 logistics. So this step focus on resource management by creating specific supply items for food, water, and organizing them into a unified supply batch for the transport. So next is the TC3 mission deploy. So this stage officially launched to the operation by creating a mission starting with the M001 and liking the previously defined community supply batch and responder together. So next we have a TC4 mission cost. So this case executes the compute mission cost. So function to determine the total financial units required for the mission. So which is an example of equals 2193.75. So next is the TC5 efficiency. This test evaluates the mission effectiveness by calculating the ratio between the supply provided and the actual needed of the community. So next TC6. So on the TC6, we have live intel. So this represent the real-time data updates where the field report cause urgency index to increase some 9 to 11 signaling height crisis. So on our next is the TC7 priority score. This case trigger the recomputation of the mission's priority level based on the new data, so resulting in a critical status score of 88,000. So on our next is our TC8, so personal eval. So this setup updates the performance record of the by responder 1 by integrating the mission efficiency data and success rating of 9.5. So next or the TC9 batch revision. So this represent a mid-mission adjustment where the additional medicine is added to the existing supply batch to meet the changing demand. So next is the TC10. So recosting. So this ensures the financial accuracy by recalculating total mission cost of account for additional items added during the batch revision. So TC11 reinforcement. So this step manage the personnel scaling, assigning the second responder Pedro to provide the extra support for the ongoing operation. So next TC12 mission report. This is the last. So this final case concludes the workflow by generating, displaying, and comprehensive after action dashboard that summarize all mission data and the outcomes. So that's the our slide about test case TC1 to TC12. So let's proceed to the slide number 9 after action mission report TC12. So on this TC12, the terminal output on the left server as the raw technical log of the operation, detailing specific personnel involved breakdown of the three types of cargo delivered. So, and this result, the final mission cost. So, the key metrics panel on the right provide a high-level summary of the mission, highlighting critical data points such as 88,000, priority score, and the final efficiency rating of 0.83%. So, this ultimately this slide synthesizes all previous computation into unified dashboard to provide a transparent data-driven evaluation of the mission, overall performance, and logistics. And that's my part for our short slide presentation. So again, I'm Christian Garcelan. Thank you.
Greetings, I'm Cassandra Sante, and today I will present the structural architecture of our disaster response command up system, object-oriented framework designed to coordinate field personnel and affected communities and relief logistics. Starting with the person class at the top center, it serves as our root superclass, utilizing private visibility for the name and sex fields to ensure strict encapsulation. So in our code, this data is protected and only accessible through public getters and setters connected to it are the responder and coordinator classes via an inheritance relationship. Signified by the open triangle arrows, this represents as a formal is a relationship where both subclasses inherit the base identity of a person while adding role-specific data through superclass chaining, where the super keyword in our Java constructors ensures the parent's attributes are initialized before the child's unique fields like ID and assigned zone. The mission class acts as the central orchestrator of our operations, managing the core logic for deployment. It uses private attributes for variables like distance, difficulty factor to prevent unauthorized modification during our complex compute mission cost and efficiency calculations. You will notice an aggregation relationship here, implemented in our code as a least responder. The hollow diamond implies the responders possess an independent life cycle and can be reassigned to multiple missions without being destroyed. To the left, mission is linked to the community class through a single association line labeled targets, which allows our mission logic to retrieve the community's population and urgency index to drive the compute priority score aggregation to manage a list of batch items. This class functions as specified or specialized wrapper in our code, pairing a specific quantity with an individual supply item, which stores the fundamental values and ways used in our automated transportation cost formulas. And that's all. Thank you for
Now,
your
hi,
time and
greetings
attention.
everyone. I'm Maple Franco and I'm part of the group 4 in 2CSA OOP. So, I will discuss the class relationship and multiplicity discussion. So, first we have the person responder. So, in OOP, inheritance means one class acquires properties and behaviors of another. Here, responder is a child class and the person is your parent or abstract class. Since person is a abstract, it cannot be instantiated on its own. It only exists to be extended. So the responder class inherits name and sex from person, meaning you do not need to redefine those as- attributes inside responder. On top of that, responder introduces its own attributes. So it has ID, assigned zone, and performance rating, as well as a method computer performance score, which calculated how well a responder is performing based on their mission history. So the multiplicity is one to one because every single responder object that exists in the system is one person. There is no scenario where a responder exists without a being a person, and no scenario where one responder maps to multiple persons. So number two is person and coordinator. So this follows the exact same inheritance structure as responder. The coordinator extends the abstract person class so it also automatically gets name and sex. What makes coordinator different from responder? It is their purpose. So while a responder goes to the field to deliver supplies, a coordinator manages and oversees the operations from a higher level. That is why coordinator adds the manage mission method, which handles the assignment and supervision of missions. The multiplicity is again one to one because every coordinator object is exactly one person, so they share the same identity just with a different role attached. So number three is supply item, food pack, medical kit, water unit. So inheritance one to one. So supply item is another abstract class that acts as the general blueprint for all types of the supplies in the system. So the three concrete subclasses, food pack, medical kit, and water unit, each represent a specific category of relief supply. All three inherit the common attributes such as item ID, category, base value, weight, and priority level. So these attributes are shared across all supply types. So defining them once in supply item avoids code duplication. So each subclass can then add its own unique behavior or override how things like value computation work depending on their type of supply. So the multiplicity is 1 to 1 per the multiplicity is 1 to 1 per subclass instance. When you create a when you create a food pack object, that object is simultaneously one supply item, so you cannot have a food pack that is not supply item. So number four, which is the supply batch supply item. So composition one to one. So composition is a strong form of ownership. It means one class contain another and the contained objects are fully dependent on the container. In this case, a supply batch contains one or more supply item objects along with their quantities. The items are added through the add the item then QTY method. The reason this is a composition and not just aggregation that is the group items inside a batch are managed entirely by that batch. Their existence and tracking within the system is tied to the batch they belong to. The multiplicity of 1 to 1 means one supply batch must have at least one supply item. An empty batch makes no logical sense in the system, so you cannot have zero items in the batch. So next one is the mission supply batch. This is a aggregation one to one. So aggregation is a weaker form of ownership compared to composition. The contained objects can is exist independently of the container. A mission aggregates one or more supply batch objects. So because the batches are prepared beforehand and simply assigned to a mission when needed. If a mission is cancelled or complete, the supply batch objects are not destroyed, so they can be reassigned or still exist in the system. The multiplicity of 1 to 1 means that every mission must have at least one supply batch assigned to it, because a relief mission with no supplies to deliver has no purpose. So one mission can carry multiple batches depending on the scale of the operation. Number six is the mission and responder. So the aggregation 1 to 0. So this is also an aggregation because responder objects are independent. Independent. They are registered in the system regardless of whether they are currently assigned to a mission. The mission class holds reference to the responders assigned to it. So the multiplicity here is spread from both sides. From the mission side, a mission must have at least one responder. So that is one. You cannot execute a mission you cannot execute a mission with nobody assigned. From the responder may be assigned to zero or more missions, so that is zero. A newly registered responder has no missions yet, but over time they can participate in many. This is bidirectional reading or of multiplicity is important for understanding how the two classes interact. So number seven is mission to community. So association one to one. So association is one of the most general type of relationship. So it simply means two classes are connected and interact with each other, but neither owns the other. So community objects exist in the system independently and are not created or destroyed by mission. A mission targets one or more communities, so that is one, because a single relief operation can cover multiple affected areas. On the other side, a community can be targeted by multiple missions, so that is one. Over time, especially since the urgency index of a community changes dynamically to update urgency, which may trigger a new missions to be dispatched to the same location. Neither class is the owner here, so they simply reference each other. So the last but not the least is the number eight, the coordinator to mission association 1 to 0. So this is a directional association, meaning the relationship flows from the coordinator to mission. The coordinator the coordinator knows about the message. The coordinator knows about and manage the mission, but the mission does not necessarily depend on the coordinator to function. A coordinator uses the manage mission method to oversee operations. The multiplicity of it was 1 to 0, means one coordinator can manage any number of missions, but none of all, okay, from none at, not from none at all.